Hey guys and girls, this is Saima Parveen. Today we are going to learn about the cryoscopy technique. Cryoscopy is actually derived from two words. Cryos means frost or ice and scopia means observation. Moving towards the short history, French chemist Francisco-Marie Roald and German chemist Ernest Otto Beekman invented the Beekman differential thermometer and freezing point depression apparatus. Francisco Marie-Rold published How Solute Depresses the Freezing Point of Various Solvents. He concluded from his experiment, if one molecule of a substance can be dissolved in 100 molecules of any given solvent, then the solvent temperature is lowered by a specific temperature increment. Based on Rold's research, Ernest Otto Beekman invented the Beekman thermometer and associated freezing point apparatus, which was a significant improvement in measuring freezing point depression values for a pure solvent. Freezing point depression. It is a qualitative property observed in solutes or solutions that results from the introduction of solute molecules to a solvent. The freezing points of solutions are all lower than that of the pure solvent and is directly proportional to the molality of the solute. Here an equation is given where delta Tf is the freezing point depression, Tf solution is the freezing point of the solution, Tf solvent is the freezing point of the solvent. Kf is the freezing point depression constant and m is the molality. Adding solutes to any ideal solution results in positive and increase in entropy. Because of this, the newly altered solution's chemical and physical properties will also change. The properties that undergo changes due to the addition of solutes to a solvent are known as colligative properties. These properties are dependent on the amount of solutes added and not on their relative identity. Here you have two images. One is of only solvent and other contains solute along with solvent. Due to the presence of solvent and solute together, the entropy increases. The solute, in order for it to exert any change on colligative properties, must fulfill two conditions. First, it must not contribute to the vapor pressure of the solution, and second, it must remain suspended in the solution, even during phase changes. Because the solvent is no longer pure with the addition of solutes, we can say the chemical potential of the solvent is lowered. Chemical potential is the molar Gibbs energy that 1 mole of solvent is able to contribute to a mixture. The higher the chemical potential of a solvent is, the more it is able to drive the reaction forward. Consequently, solvents with higher chemical potential will always have higher vapor pressures. Freezing point is reached when chemical potential of the pure liquid solvent reaches that of the pure solid solvent. Again, since we are dealing with mixtures with decreasing chemical potential, we expect the freezing point to change. Unlike the boiling point, the chemical potential of the impure solvent requires a colder temperature for it to reach the chemical potential of a solid pure solvent. Therefore, a freezing point depression is observed. For an ionic solution shown in equation 2, the dissociation particles must be accounted for the number of solutes particles per formula unit. I chose the Van 't Hoff's factor. It is worth mentioning that these equations work for both volatile and non-volatile solutions. This means that for the sake of determining freezing point depression, the vapor pressure does not affect the change in temperature. The non-mass of added solute and the freezing point of the pure solvent information permit an accurate calculation for the molecular weight of the solute. Here we have cryoscopic procedures. It consists of cryoscopy apparatus, sample and solvent selection, and cryoscopy method. Moving towards the cryoscopy apparatus or chemicals, it consists of thermometer, test tube, pure solvent, beaker, ice water, and magnetic stir plate. The second, sample and solvent selection. The cryoscopy method may be used for a wide range of samples with various degrees of polarity. The solute and solvent selection should follow the premise of like dissolved like, or in terms of Raoult's principle of the dissolution of one molecule of solute in 100 molecules of a solvent. This table shows the cryoscopic constants for the common solvent used for cryoscopy. It consists acetic acid, benzene, camphor, carbon disulfide, carbon tetrachloride, chloroform, cyclohexane, ethanol, naphthalene, phenol, and water. Cryoscopic method. First of all, weigh 15 to 20 grams of the pure solvent in a test tube and record the measured weight for a value of the pure solvent. Place the stir bar or wire stirrer in the test tube and close with a rubber stopper that has a hole to encase a mercury thermometer. Place a mercury thermometer in the rubber stopper hole as shown in figure. Immerse the test tube apparatus in an ice water bath. Allow the solvent to stir continuously and equilibrate to a few degrees below the freezing point of the solvent. Record the temperature at which the solvent reaches the freezing point, which remains at a constant temperature reading. Repeat the freezing point data collection for at least 2 or more measurements without a difference less than 0.5 degrees centigrade between the measurements. The observed freezing point of the solution is when the temperature reading must remain constant. Sample calculation to determine molecular weight. Here we have 3 trials, and then we had taken the average of each solvent. Like the parameters we have measured is the mass of cyclohexane, mass of unknown solute, freezing point of cyclohexane, and freezing point of cyclohexane mixed with unknown solute. And then we have taken the average of all these. Here we have calculation of molecular weight using the freezing point depression equation. So calculate the freezing point depression of the solution from equation given below. Here we have find the freezing point depression from the equation third, and then we calculate the molar concentration of the solution using the freezing point depression and Kf. As we know that T delta F is equals to Kfm, then we can find out the molarity by rearranging the following equation. By putting values, we have got the molality is equals to 0.113 molal. Then for calculating the molecular weight of unknown sample, we had taken I is equals to 1 for covalent compound as in equation 2. Then we calculate the molecular formula from the given equation number 5. Pros and cons of cryoscopy. It contains many pros like simplicity, ease and accuracy. It is applicable to liquid or semi-liquid material and cannot be used with non-liquid systems. It performs rapid and inexpensive measurements, whereas it may not be suitable for higher molarity or colloidal solution. Can be the cons of cryoscopy. There are various applications of cryoscopy. It is used for the measurement of enzymatic hydrolysis of lactose, for determining added water in milk. In medical use, it has been limited mainly to physiological and clinical research for measuring total solute concentration. For water activity, measurement of non-liquid foods.